Welcome to Retro Upgrade. Today's episode is a little special. It's the end of the year episode, and on top of that, I received my PCB boards from PCBWay. This is a special project video for PCBWay. They are sponsoring the boards and the episode, so give them some love. Will I be able to get my first ever designed PCB working actually? I'm not sure because I had never built an analog circuit or anything else actually to a PCB. So this is my first time and I'm quite a noob at this, but hopefully it goes well. More on PCBWay's offerings later in the video. Now let's get to it. Welcome to Retro Upgrade. Today will be a special episode. This is sponsored by PCBWay all the way today, because I got some parts from them, and this is a project video. Today we'll be tackling not the keyboard. I'm still waiting for parts for this one. They are on their way. I need to fix that. But I actually got some nice goodies. Got some PCBs. These are the keyboards. Show them in another video. Also here. So the full disclaimer, all the PCBs were provided by PCBWay, of course. They are my sponsor after all. They did an amazing job. I looked at them last time on the boxing of the Christmas present. I have a mountain of stuff here. So I designed and ordered some RGB converters for the ZX Spectrum. This is not my design completely. The SMD part I collabed with Detlef, Detbuildsstuff. You have his logo right there. And I'll explain how this came about. So I got my first ZX when I was at the flea market. I never had one. I never used one. But as you all know, it has RF out. I already modded it to composite in the last video, and it gets a pretty good picture now. But I do want to be able to record it, so I thought, well, this should have some type of good output, and it turns out it has YUV, so it's composite component video out. But I've heard that it's quite noisy from the pins right here. It's actually pinned out in one of the pins, or three of the pins here. Can't really remember which, but I have them here. So this is the bottom side. So from the bottom pins on this side, you can get them. You can see here I have the breakout. Okay, enough chatter. I got 5 populated ones with all the components on. The PCBWay did this. We're going to zoom in and take a look at the quality. And I got 5 unpopulated ones, just in case if I screwed up somewhere and I have to do some modding, some budge wires and stuff. Because this is my first designed board. I'm not a PCB designer by any means. So this could actually not just work, pretty much. Okay, so the astute of you probably noticed this doesn't go in here, obviously. So what I got, you can't get the connectors anymore for the ZX Spectrum with the small notch, but you can get these. I'll show them up on the screen, which ones I got from AliExpress. It's a 56 pin, I think, or 58, I can't really remember, but you need to modify these to make them work. You need to take out the pin right here. That's the 5th one on the left, for example. You can just pull them out or heat them up from this side and just push them through. We're going to be doing that. And then what you do, you put in some kind of shim on the 5th pin, so you can't shift it to the sides, so you don't short anything out, because there's 12 volts, 9 volts, 5 volts. So hopefully that works. The idea, at least, is to put this like this, bend the pins down, so you sandwich them. See if you can see, just bend them in, and then get the solder them to stick, and hopefully that would make a solid enough contact to be able to contact this. This is hand routed, so what you see here, there are all traces that go around to the pins. So this is actually expansion port, so you can plug in another cartridge on top, and it should go right through. Now, let's see. Okay, so let's zoom in. I got the entire bag. I think it was like 5 or 6 euros. These connectors. If everything goes well, I can consider selling these. It looks good, but I've heard that the signal here is really noisy. So this is actually just a version 0. So this is actually going to be used to determine what is creating the noise, and if I can actually reduce it with high pass, low pass filters, and maybe I don't know what it's called, notch filter, I guess, or something like that. So you use the signal that's introducing the noise, invert it, and then you cancel it out at the pins. And last resort, I actually put some pins here to connect directly to the ULA. You just solder wires and put them here just for testing. Also, I put in some power +5 and ground, just in case if I have to keep it outside. But considering there is a commercial product, this one right here, it's ZX HD, it's HDMI out, and they get a pretty nice picture out, so why not? This will be a lot cheaper though, because it's RGB out. I decided on the Sega Saturn plug. This is a 9-pin DIN, mini DIN connector. And this is extra, because this is routed to here. The Sega Saturn SCART cable has audio out as well. This is just extra if you're connecting it to a screen that doesn't have speakers, you can plug this in. I really like the design and the quality. Let's zoom in a bit so you can see it closer. So this is my first PCB ever I designed. Of course, with some help from Detlef. So the story is, I was lying on in a hotel. My daughter was at a birthday party at the hotel, and I was lying on the sun chair, and I was looking at the schematics for the ZX Spectrum while she was jumping around swimming. So, and I noticed there were YUV connections on this, on the ZX Spectrum. And I thought, why can't you convert that to RGB? And it turns out people have done that before. There's even a commercial product. I can show it on the screen here. The problem is those are extremely rare, expensive, and hard to find. So then came the next one. Had someone made something similar from scratch? And they actually had. I actually found the schematics for the original product from, I think it was a French product. But the schematics were a mess, and Detlef refused to remake them in SMD. So I found the alternative, the other one that made one of these, and it was so clean and nicely designed. There was some missing information about the components used, for example, what type of transistors were used and stuff. I'll show the schematic on the screen, but I found a page that detailed everything I needed to know, so that helped a lot, and hopefully that works. Okay, so let's see. Oh, I think I screwed up on the name here. Mega Drive 2 Mini DIN 9. It should say Sega Saturn. Or maybe it's the Mega Drive too. I have to take a look. Okay, so let's take a quick look at this. So this is the number PCBWay gave it. That's not my silk screen. The rest is I put some test pads, blue, zinc, red, and green. And you also have trim pots for each section. On the schematic, they are divided into sections and with the trim pots. This is, we have to take a look at the schematic, but there are only 2 chips on this and then some transistors. You can see them here. And this is analog pretty much. And the analog circuitry is not my strong suit. I just followed the schematic on the web and found some suitable replacements from the through-hole versions they used. This exists in through-hole, this as well, but the rest of the values are exactly the same as the schematic. The only thing I used was making sure it was small and compact. And here you can see the mess of wires that if you want to do a through connection. You see all these small wires I had to hand route to the other side. You can use auto router, but it made a huge mess of it, and it used vias, these small holes everywhere, and made it really hard to know what was going on. If I'm going to do some troubleshooting on this is quite easy because it's done in sections. For example, this side is the sync together with this. And I have the red one here. That's the section for red, and this is for green. So I know exactly where I need to go to fix something if something's off. For example, if I get a blue image, probably the green and red are not really working well. Okay, so next step, let's solder on a pin header on this side. I think it was. Yes, this is the bottom side. And it should go like this in. The notch makes it easy. So we need to modify this first. The mod consists of cutting off or sawing off a little slot on each side so it can go into the main board, because the main board doesn't have any cutouts on the sides to accommodate for the pin, and as you can see, it's a little too wide. So we need to take off 0.5 millimeter from each side. It's quite easy because you see the bend here. It goes exactly down to the other side with the same bend, and it's where you need to cut. So that's perfect. And for the 5th pin, I was thinking of trying to push it out. 1, 2, 3, 4, 5. This one right there. Sometimes you can heat them up and just push them through. I can test that. But because it has 2 sides to it, maybe it won't work. Oh, they are separated. Cool. Then yeah, we can try to heat it up and push it through. I've had that experience before with these. You heat them up and then the pin falls through. So hopefully it's the same for this. Okay, let's get started. I'm using a really chunky soldering iron tip for this. I am going to try to hold this and count. Maybe it's better if I mark which ones need to be removed. So if I'm going to put it like this, 1, 2, 3, 4, 5, right here. This color is not great for this. Let's see. 1, 2, 3, 4, 5. I can probably 3D print a shim that goes right in the hole, but for now I'm probably just going to use something to put in. Okay, let's turn on the soldering station. 350 degrees should be enough. I have some solder on the tip just to make a better contact. But I will clean it off as soon as it gets hot. I will try not to touch the other pins on the sides. I'm sorry if I'm quiet. I'm trying to concentrate. There we go. Flow out quite nicely, actually. I got the 5th pin. Now for the other side. Oh, the markings are helping. 1, 2, 3, 4, 5. There we go. That was really easy. I wasn't expecting it to be that easy, but it's nice when it works out. Now we have the small opening right there. So the best thing is just to put in something that fits, and then you can't fit it through like this. Let's see if we can. Yeah, we need to cut off the corners, otherwise it won't fit. Okay, next up. You can melt it off, you can grind it off, you can cut it off. You can do whatever you like. I'm going to try to use a Dremel or something. Would make quick work of this. Maybe with a grinding wheel or something. Okay, we'll be right back. I just need to grab the Dremel. I really don't know where I put it. Okay, I found my Dremel. It was in the in the box it came in. It's not the original one. I had the original one. It actually burned out, so I wasn't very impressed. This has probably been my main workhorse for 7 years or so. Does work. Little drastic, I guess. Could use this or something like this to grind away. If you want to go slow, go with something like this. If you want to go really fast, you go with a cutting wheel. Pretty much. I go with a little bit of both. I can't even see what value this is. Let's see. 80. So it's the same as the other. I do have a lot of bits. This is the thing you lose the most. The actual tool you use to put it together. I have some sandpaper. I can clean it up with afterwards, or the flappy wheel. But I cut off the bulk at the beginning first. So before you hook it up to power, put in the bit you want to use. I'm going with this. I'm missing the lid here, but yeah. You hold in the button, push this until it clicks, and then tighten it down. The max. It's only on number 2, by the way. I'm going to for number 1, really slow. And make sure this is stable. If it shakes too much, stop and put it on a new disk, because if it's not stable, you will probably explode it and it goes everywhere. Okay, time to do this really slowly. So this should be through. Yeah, it is. So this is why I'm going to sell these, as well as putting them up for download the schematics, because not everyone has a Dremel, not everyone has the patience or know how to do this, so why not? You can also buy these populated from PCBWay directly, so that's really nice. They're a little expensive if you just buy one, of course. So I'm also going to be offering them on some way on one page or another in the future when I know they work. This looks decent. This is exactly what you want. Barely through, and still enough plastic to protect the pins. So let's do the other side. Okay, so you can see the outline of the actual hole. That should mean this, yeah, just comes out. Okay, let's clean off the corners, sides. There's some burrs. I actually have a deburring knife I bought from AliExpress for my 3D prints. We'll be using that later. Okay, so a lot of black dust everywhere, especially on my hands. Use a mask and some glasses. I do have my normal glasses on, and dust mask is really good for your health. Okay, let's see. This is not going here, by the way, but it's a good test anyway. See what I mean with alignment? If you don't have a pin here, it's really hard to align it. It fits quite nicely. This looks really good. That means it should fit the ZX. Still alignment. And trying, but these are quite sharp. Solder it from the back. Push it in. Oh yeah, this is going to be really good. And with the alignment pin in, it won't shift to the sides like this. So that's good. It's quite tight, but it's a new cart connector, so that means it's making a good contact anyway. Okay, let's just clean off here. I'm going to go get the vacuum. Okay, so let's get some measurements from the slot so I can plan to 3D print something. Okay, if we're doing any type of 3D printing, it's important to have tools. So I have an angle finder when I'm designing stuff with strange angles, and digital ones make it a lot easier to find the value. So you buy digital ones, they're not expensive. But this is my most used tool for 3D printing and 3D design. Also, I use this to make the keyboard for the ZX. So to take measurements, because I took a picture from the top and then I used the picture to put out all the spacings for the holes and stuff and the buttons. And then I double checked with this against the 3D model I made on the computer, just in case, to see if all the spacings were correct. And they were pretty much spot on. Okay, so I think the battery is about to die. Yeah. Okay, so let's hurry up. So, using the outside. Oh, you have to get them in the hole. Open them up. There we go. So I have 1.85 for the width. The height is, let's see if I can. Height is, oh, it's glitching. Wait a sec, the battery is completely dead. Give me a sec, I'll be right back. Okay, this is the problem with the electronic calipers. If you don't have any of that, the batteries, you are pretty much screwed. Okay, let's see. Should have something that fits. These are not the same thickness, but I think these will work anyway. These are CR2025s. These are 2032s, so this is a lot thicker. Not a lot. Let's see if this works. On off. No, it does not work because it doesn't reach. You see? This could be faulty actually. Let's take another one. This is a Maxwell branded one. That one worked immediately and it's a 2025. So this one is probably dead. I have a small baggie of them. Zero it out. Doesn't complain about the voltage or the, yeah, that's how it measures the, if it's out of battery or not. Okay, let's do this again. Loosen this. You always put it to the side, just close it completely, press 0, and then you can use this to adjust so how much drag there is, so you don't fly across. Okay, so let's see if I can give you a better shot. You see these two pointy things on the back? I'm using those to measure 7.23. And then let's go for the width again. 2.14. So it's a little bit plus minus. So if I do it 7 high and let's say 1.9 wide and deep, yeah, let's see. You have this that protrudes on the bottom. You can use for the depth of stuff. You just push down and you get 9.5. So I don't need to go all the way through because the slot is quite deep. So let's say 7. Let's write those down. And of course, if I put in a 3D printed part here, a small slot, I will glue it in because it doesn't need to move from there ever again. Okay, so let's find something to put in here for now. I'm not going to be 3D printing right now because otherwise this video is going to be way too long. Let's put away the calipers. Don't forget to turn them off so it doesn't eat up all the battery. So for now, let's focus on getting this soldered on. So it goes soldered on this side where the markings are. That's at least how I designed it. But if you solder it on here and plug it in, will still work, but yeah, it will still work actually. But you have to plug it in upside down and then the connector is on the other side. It's better to have it on top like this. Okay, so what I was thinking is bending equal lengths from both sides. Like this, bending them in, but equal distances. Let's see. Having the PCB on at the same time, you can squish against it, helps a bit. This is kind of janky, I know. That's the only way to get yourself a connector for the ZX nowadays. Just a bit, go slow and then brush them in a bit more without the PCB. Metals have something called plasticity and it deforms and then it goes back to its original shape somewhat. So if you go over a threshold, say over half, so it stays deformed. You see some of the pins are still straight. That's because of the plasticity. Things you learn when you learn how to weld cars and stuff. Because when you bend metals, sometimes they are a pain in the ass to keep there. So that looks decent. Still want to bend them a little bit more, so they grab on. So the bottom row is not as bent as the top row. So you can use some kind of flat edge and bend in with the flat edge, just squeezing them. I'm going by hand now, really slow. You just want to do this once, the bending. At one side, you don't want to go over, because when you bend a pin back and forth, it breaks. Pretty much. Let's see, how does this look? Better. And then from the bottom, let's start bending up. So if you go over a bit, doesn't matter, because you will use the PCB to bend them out again. So if it pinches the PCB in multiple places, it's actually better. Trying to make it as fixed as the PCB. Okay, so I'll put it in from one side. Yeah, it's grabbing now. So you can see most of them are touching. This side is definitely touching all of them. So this should be enough to make the cart work. You could go in and press with something exactly near the PCB. You put in the PCB, get some not tweezers, something really strong. Let's say something like this. Just press when they're close to the board. So you have to press in, keep it straight, and then just squeeze them. But that's actually not necessary, because this will probably be strong enough. So now I need to find a way to keep this pretty much in line while I solder them. Easiest way, probably helping hands. I have two of them. These ones are quite flimsy, and the crocodile teeth are not really strong, but that's actually positive right now, because it doesn't break. Can't actually fit around the connector. So that's going to suck a bit. Let's see if we can make this work. No. So this one is out of the picture. Maybe it can hold the PCB in place, and this one holds the... Yeah, this one can actually hold it from inside. So you just need to tack in two of them on each side, and you should be ready to go. So I screwed up here. Do you see my error? I have this upside down. So either I can turn this upside down, like this, or the other way around. So I just do this because this is harder to put on. So big tip here, use flux. and a lot of solder. So you can pre-tin the pads if you want, but wouldn't recommend that because you will get a little bit of a gap because you can't bend the pins close enough. Of course, they're springy, so maybe that would work. Okay, so let's go for this one, and then look on the back side and see if they're close enough, and then go for the rest. And then we can use the, oh, what are they called? Pliers to push in the rest so they do touch. But I can see this is really nicely aligned already. Let's go for the soldering iron. Have it at 350. We'll need some flux. I have my spooge flux right here. Homemade. I have some IPA. And I can't find my solder. Oh yeah, here it is. And my really thin solder people complain about. Okay, we can remove the batteries so they're not in the way. Move this. Make yourself comfortable, not the piece. So this should be comfortable enough to solder. Let's put on some flux. So the reason I tack in one corner of each is just in case if it's misaligned on the other side, I can actually go in and fix that. Just heat up one corner. If you solder them all, it's pretty much impossible to move it. So keep that in mind. Soldering iron, I'm using a big fat tip. Just putting on a blob. Yep, that's holding it in place already. Let's do this corner. See, it's a little out, this corner. So what I'll be doing is putting on some flux, holding it in, and then putting on some solder. This is a little awkward for me to film, so sorry if you don't see anything. This is my first ever project video with PCB way as well. Many more to come. Because I like designing stuff. Okay, so yeah, so it's not aligned really, so I have to remelt this. There we go. That's what I meant with one on each side. There we go. That's firmly soldered because it's going to be a lot easier when it's stuck down. Okay, so let's let these go. On the other side, do the same procedure. And they are pretty aligned actually. I can't really see a misalignment anywhere. See, that's good. Same process. Flux. This time I put it on both because I know it's about right. This will not be this nicest looking or most professional install job. This is just prototype, and it's for myself. So not really happy with that joint. So let's put on some more. There we go. That looks a lot better. then the last one from so let's put on some. There we go. Looks about right. Okay, let's inspect our work first, and then we'll continue with the soldering. Okay, we're under the microscope. Let's take a look. Let's clean this off first. Sorry for the blinking lights and stuff. It's the light on the actual microscope that's making it way too bright. It looks pretty decent. I'm going to be changing out the lights on the microscope in a very short time. I bought some LED lights to try it out. Well, it looks decent. It's completely soldered underneath. I maybe can do another pass. Let's turn this around and look at the other one. I need a stiffer brush. That looks decent enough. Of course, solid. Let's see here. This is the other side. Well, that's good enough. So you can see what I wanted was for all of these to touch. And they are. They're touching the metal. They're a little bit offset to the side, but that doesn't really matter. Let's see this one. This one needs a bit of a touch-up. Pretty much, but it looks decent enough to work. Okay, so let's go through and solder all of these. I'll do that on the normal camera because having the microscope right here is a bit of a pain. If you want to see the quality of the solder from PCB Way, it's not bad. This is all pre-made from them. Of course, I wouldn't expect anything less from a good PCB manufacturer, but still. Sorry for the blurry camera. That's the camera's fault and the light source. But these joints are really nice. So they probably use a reflow oven or something like that. Or maybe a solder bath. No, they can't actually with SMD products. So they probably just use a solder paste and reflow. Still very, very good.
Now a word from a sponsor, PCB Way. So if you want to order a PCB, you just upload your Gerbers you get from your PCB software. You can also view them with their Gerber viewer. This is really handy. You can notice faults or surface finish problems. I forgot a silk screen here, for example, I noticed. It's on the main thing. And you can also see the transparency. I opted for 10. I leave most things at default. Because I have an edge connector, I have to check that box. And I changed from hard gold to HASL because it was too expensive otherwise. I also left everything else at standard. You can ask for special treatment of different things or remove the serial number they use for tracking. Really not necessary for prototypes, obviously. Here's the important part, assembly service. So you need to have your bill of materials to know how many components there are to fill out this correctly. I opted for 5 populated boards. Here you go. Here's the bill of materials for me. So you have to count how many unique things you have and put that in, and then also the total amount of components. So you can just mark everything and do a sum, and you can actually calculate it automatically. Here we go. Should 49. There we go. So let's copy that over. I have 21 unique components and 49 components total. I clicked on order, and then you get a preliminary price. You just wait a little while and you get the full price. You can upload your BOM again. I got 75 euros. That was reasonable for 5 units. Thanks a lot, PCBWay. Now back to the video.
Okay, we're on the overhead camera. Let's solder down these. I'm just going to check so all of them are touching, or at least very close to touching. Push down the ones that are look a little suspect. So it doesn't move. I use my helping hands, and I would like them to face the other way. That doesn't move that much. These are all touching, so I would not recommend drag soldering right now, because these pins are way too big for that. You would have to have a massive solder blob on your tip, and that wouldn't work out that well. Let's go one by one and make sure they all have good contact. On my toothbrush, and let's turn off the soldering iron for now and clean off the pins. Let's inspect our work again. See if we need a microscope, or we can do it on the overhead. I can probably do it on the overhead. Okay, let's look at the pins. Not really my best soldering job, but they're all connected. They look decent enough. It's straight-ish. It's straight. Just the camera view looks like it's bent. And what you do to make sure it's on, go one pin at a time, and push them to the side. If it's loose, you resolder it. Really good. I'm happy with that. When you're doing this, you have to be careful with this. That's why I'm going to be pre-selling these with this already soldered on, so people don't get annoyed or give up. There are people that don't know how to solder. It's a good skill to learn, but maybe you just want the connector, so I'll make your life easier and just offer that as well. Okay, so let's look over this side. So problem here is they are in there, see? But because we have one side soldered on completely, what I can do is go in with some pliers or something and just push down and bend, or do that while I'm soldering, just to make sure they make contact. I would do this before soldering, so like this. Now that's somewhat making contact. So I need to push these down while I'm soldering, so one of each. So what could have prevented this is bending these farther down when you have the board out. So they start out bent a lot more. But I think they are close enough so the solder will reach even if they're in there. I would rather not have them in there, obviously, but I don't have the luxury of redoing this too many times. I only have 5 of the populator boards, and I do want to make the video so short as possible. So what you do now, flux on all the pins. The 3 important lines are these 3 that come from the underside right here. You can see them going from here, these 3 pins. So, and the power, of course, comes from one of these. But for now, that looks fine. Let's make a small shim and put in here. For now, I'm going to do the 3D printed parts and make it available for people that want to make this themselves. Otherwise, you can buy it pre-built. Okay. A sheet of paper. I should use the scissors for this, but it's just for testing. I'm not going to do this if I'm going to sell this, obviously. That would be horrible. I wouldn't put it past some companies, but I don't want to be one of those. So yeah, that's about right. Just need to snip off there, and it should prevent it from going in sideways. So need some scissors. So I just eyeballed the size pretty much, and it seems to be decent. Okay, so I have to put in the bent side first. I can always pull it out with some tweezers. Okay, so this should prevent it from going in sideways. Pins are still straight. Okay, let's try this out on the ZX. See if it aligns my thingy. It does. It actually worked. So you can see the piece of paper right there, exactly in the middle. Let's pull this out a bit. Just want to see if the pins are aligning. And they pretty much are. Could go a little to the left, I guess. When you push it in all the way, it goes to the left. Okay, perfect. But the misalignment is not that much, so the pins should be touching all of them. They're pretty much dead on in the center, actually. Perfect. We have something to test. Okay, let's turn this on. Nothing. Maybe I have to tweak settings. RGB S should be that. That decent. But I need to check the signals and do a comparison, and my cable is not doing so hot either, so you can see here. So maybe it's the cable that's broken inside. I'm going to open it up and take a look, because it's been opened before. Could be that the wire's loose. Okay, we're back. It's working now with the connector. It's just me choosing the wrong channel. So the RGB is not working. So I need to investigate on what's going on. Maybe I designed it wrong. Who knows? If I hook up the RGB while the RC or on the composite, I get instantly the logo. Okay, we know it's working. Let's switch over to this card. It detects the 50 Hertz signal, at least. But it doesn't do anything else. But it doesn't say no signal. So it has a video signal coming in. It's probably just not strong enough or something else. Okay, before we give up for today, let's see if we can figure out what's wrong. If I screwed up somewhere here. Maybe the cable is broken. Or in worst case scenario, something's wrong with this. It's quite dirty. Could clean these. Let's see. Let's start with the easy stuff. Oh, I just remembered. This has potentiometers. Maybe they are just off. Huh. We'll take some measurements with the what's it called? The oscilloscope. Make sure. But first, let's clean off the pins thoroughly, because they look very, very dirty. Yeah, better. Let's try this. Card in. Buenas noches, babies. Let's connect this up again. The reason I could think it's the cable, this is loose inside, so I have to open it up. It's been open once before, so that makes me think it's already broken. But let's give it a try. Oh yeah. Power is out. Okay, here chirping. It switched to SCART. Buzzing. But no picture. Okay, let's start probing around. I have the mini oscilloscope I borrowed from Richard. Let's use that. Should be fine. Let's make some space. First, we need to check if these pins get a video signal. Could be that they don't. So I'm not very familiar with oscilloscopes to begin with. So if I do something wrong, sorry. Still learning. Let's remove this. So we clip this to ground because negative is pretty much in center. This one should be ground. Okay. Let's put this so you can see it, and so I can move around as well. Yep, that's visible. Okay, well, let's see what we can do here. We put it on AC because it's an AC signal, I think. 50 millivolts per division, 60. Okay. Oh, so there is something. Let's see if we can make it trigger. How do I set the trigger point? Select. Oh yeah, there we go. So there is something on the Y. Let's see the V. Yeah, there is something too. Let's see if I can make it trigger. There we go. So there is a signal. Looks to be in negative numbers. Of course, in AC it doesn't really matter. See, this should be 0 here. Okay. So it's about 1.2 volts at the peak. Right there. It's not too bad. And this is the U. Should be the same as the V for a white background, and it is. It's just the Y that's completely different. You can see the peaks here. So that peak is probably the text on the bottom. So it is quite unstable. If that's normal. I'll check right here where the pins come from. Oh yeah, right, on the back side. Okay, I'll be very careful so I don't short anything out. Okay, so I need a ground point for this. Is that ground? That should be positive, right? I just hook onto the same resistor or capacitor I had. Yeah, let's see if we get the same signal. We do not. Oh, I hooked it up on the wrong place. Okay, let's see if replicate. Yep, we have the same signal. Don't forget I flipped it over, so. There's the same signal. Cool. Okay, so I should be getting something. 4 pins right here. That's blue, sync, red, and green. So let's see if I can zoom in for you a little bit. There we go, something like that. Yeah, that's good enough. Okay, so let's take a look what we can see right here. Can I reach? First of all, yes I can. Okay, blue. So there is a slow signal. Some kind of signal. 2 seconds. Okay, so it's not triggering because it's really low. It's about half a volt. There's the trigger. Okay, so it's standing still. And it has some kind of noise. Okay. Red should have exactly the same. Looks like it. And green too, because it's mostly white. It actually looks quite good. Sync signal, do we have any? We do. The big wide signal is when it goes the vertical blanking. So this is this is actually seems to be working. So could be the cable then, hopefully. Wonder what happens if I adjust the pots. Okay, so let's get a screwdriver that fits. And go very slow. Okay, so let's take the blue pot. I'll put it on blue. I have to put this on an angle so I can see what I'm doing. Has a little stand. Can you still see? Yeah, you can. Perfect. Okay, so blue. Still get a signal. Good. Now let's try to turn the pot. I'm not reaching in. Let's change out a bit. Let's use a flat screwdriver. I know these I can see what I'm doing with these. Okay. Let's see what this does. Okay, this is too big. I forgot about the pots actually. Don't see any difference in the signal. Oh yeah, goes higher. Oh, okay, so I regulate the signal strength. It should be around a volt. Half a volt. I don't see anything on the screen yet. Let's see how high these are really. 600 millivolts peak to peak. Okay. When I adjust this, going backwards, no? $600, so it doesn't change the millivolts. It has a 15.6 kilohertz signal. Sounds about right. Oh, I'm changing the frequency. No, I'm not. Yeah, so let's change all of them up a bit. Let's go for it. Should I go for DC? DC coupling, blue. Let's see if I see any difference touching the pot here. So it goes up in millivolts and then goes down again. We don't know what these pots are for. Shut. Oh, if you couldn't see it before, this is the loose wire. It goes right there. I will probably be touching up all of the joints. Flux. Okay, let's see. Let's try this again. I plug this in without the shielding or the plastic casing. Let's see. Yeah. That should be in. That should be okay. And moment of truth. Do I get a picture? Or does it blow up? Nothing. Let's change the channel on the TV. See if that's 50 Hertz. SCART. Nothing. Only blue. I don't hear buzzing though. This buzzed before. Did I hook in the wrong? No, I did not. Did I screw it up somewhere? There we go. Now it's buzzing. No picture though. That's annoying. So the cable was broken. Broken further down the cable, maybe. Wiggling the wires, see if that works. Nothing. Oh well, time for some real troubleshooting for next video. I gave it a shot. I don't know what's wrong here. So I'll have to read up on analog video and see if the values are correct for what I'm seeing at the plugs. Maybe I need to. No. Video signals should be visible either way. Okay guys, this is the day after. So you can see I have a faint picture and it is connected to my RGB thingy. So the problem was the actual plug was either it was shorting somewhere or damaged, so it wasn't giving any picture. I tried my Sega here and it was same thing. Gave a picture 5 seconds, then it went out. So let's see. I soldered the red, green and blue wires and the sync all together on the board directly. That seems to work. So next step is to putting this plug back, soldering all the wires and I'll try to adjust the image here with the pots on the actual board, and hopefully that fixes everything. So I'll update in a few minutes. This is the day after. Hey guys, this is a few days later. Detlef was around. He came over to grill and have some fun, and we took a shot at troubleshooting this, and we found out that one of the components has died, small transistor right here, and that was making so the blue line didn't produce any picture. So I thought it was that. Turns out it works if I don't hook up the ground wires to the RGB. This is for the SCART. I used the test pads to hook up blue, red and green. If I don't hook up the ground and have the sync signal on here, it works, but very blurry. So I couldn't figure out why, because as long when I hook up the ground wires, this one and this one, it just goes haywire and shows banding all over the screen black. I can show you an example of that right here. So we thought maybe, okay, well, let's check around, and we checked this potentiometer for the blue. It showed zero ohms in resistance, so it was shorted to ground, and we noticed this one was shorted. So we took it from one of the other PCBs I have. We stole it from there and put it here, and it started working and showing a picture again. I also noticed I forgot to save and put these 5 pins floating, so they're not connected to anything. So we grounded them from here to here. Nothing special really. But then a few minutes ago, I was laughing so hard that my stomach hurt. I noticed a flaw I made, or rather, I didn't check very well in the documentation I sent over to PCBWay for them to assemble this. So this one, and this one should be NPN transistors. The only PNP should be Q9. But because I didn't check the name or the number that was on the footprint, these are PNPs. So they are being driven backwards, and it still works. So the way I'm making it work right now is taking this wire, that sync, not hooking it up here, and hooking it up directly to the TV's sync output from the composite, and stealing the sync practically. It just uses the composite for sync, nothing else. And it works, and it gives me a decent enough picture actually. So, but I'm guessing if I change out these 3 components, I'll steal them from here, and that should fix the issue. I'll go over to the computer screen and show you exactly what we did. I also modded here. You can't see that very well, can you? But I put 2 resistors in series to get 180 ohms, because for some reason one of the resistors I put on the diagram had the wrong value, 100 instead of 180. The 8 looks like a 0, so could have been I was too tired when I did that. But still, that's 180 here, or 150 something, but it's closer than 100. So, and this is probably one of the causes that this one burnt out the blue one, because it's on the same line. Hopefully that's the issue. And I don't have any more surprises. So first off, let's take a look at the screen on the computer and show you exactly what I did wrong, so I don't do it again. Okay, so we're back at the computer. Let's bring up the schematic. Okay, just broke, I guess. Okay, so these are NPNs, BC4846B, all of them. This one should be a PNP, and I marked it as such, but the footprint has a NPN transistor mapping. And I thought they had screwed it up, but thanks to PCBWay being so diligent, they actually put a PNP transistor here. The problem is these ones, the ones on the video lines, Q2, Q4, and Q5. So this number is not the same as this. I didn't notice at the time. So this number corresponds to actually a PNP transistor. So that screwed me over quite a bit now, because now I have 5 boards with the wrong component on. And the other thing I noticed was this was set at 100 ohms instead of 180, like it should be. I didn't check very thoroughly, so that's my bad, of course. So let's go over here and show you exactly where I got the schematic from. So the schematic comes from this guy. So this guy made a schematic 2005, I think, if I'm not mistaken. And I followed this to make the new version. So this is pretty good already, but these components are really hard to find, and they're through-hole, and the most things here are through-hole components. So I followed this, made my own, changed a few things, but nothing major, so it should work exactly as intended. I know this is a noisy signal that's coming in here, so the signal will never be as good as it can be, but you can actually filter out the noise. I've been testing around with the oscilloscope, and the noise is about 20 megahertz. So if I put a low pass filter on all the lines, or one on each, we should get a reduction in noise, quite drastic actually. So hopefully that will improve the video quality even more. But of course, if you do what I did, wrong value here, so this is a voltage divider right here, you get the wrong value out, or instead of dividing by a quarter, it divides by half, if you have 100 and 100. So yeah, that won't work probably. And having NPN, you can see here why I screwed up. So there's no mention about the PNP or NPNs here. So I had to go to his other schematic, and you have these. TUN means NPN transistor. So TUN, TUN. All of these are TUN except for the last one on the sync. That's a TUP. So that's a PNP transistor. So for some reason I copy pasted the wrong thing and screwed myself over. Okay, let's go fix it on the board now. Back again, take 2. Okay, so as you can see, I have it hooked up. I've soldered the red, green, and blue wires and the sync. I also have connected both of the ground wires to the ground on the board. I soldered on the pins, and let's see what it does. So you can see the error. So it's pulling half an amp at 9 volts, and this is what the output I get. So this looks like sync issue to me. So I probed around a bit, and actually it actually works if we do this. So I pull off the ground wires. So this shouldn't work in my opinion, but I do get the picture. Not very clear, very blurry, grainy and some scrolling artifacts, but this still works. Okay, so let me desolder the wire over here and the sync wire and pull sync from here instead, from the composite, and hopefully that will look better. So no signal, it's not connected, the sync is not connected, but everything else is connected. I connected up the grounds. Okay, we are all set up. Sorry for the bad angle on the camera right here, because I can't really hold three things at once. Okay, so what I'm doing, I have the component connected right here to the ZX. This is the other end. And I'm taking the sync signal, this yellow one, just putting them together. It's not very stable because I'm holding it, but as you can see, the picture is a lot brighter and you can actually read what it says. So it's a sync issue. So let's try to fix that on the board. Okay. To make it easier to remove, hot air, some flux. I need to remove 3 of them. I know which ones, so that's fine. I have a hot air set at 350 at half the airspeed. Just heat around entire. Don't go all the heat on one place. Heat up the board evenly. Go. I'll save that for later because it's a PMP. I can use it as a replacement. Okay, next one is Q4. Let's see, there's Q4. This is the donor board. I'll be taking these down here. These are all the same. I don't know why this one is so scratched up. Yeah, but it is the same. Can't read. There we go. Okay, so let's go. Flux. Okay, let's hook this up to the spectrum, solder together the wires again, and the ground and stuff just for testing, and see if it works just with the cartridge without the composite lead to it. Still get this. So the sync signal creation is not working. That's a little too bad. Let's scope out. Okay, so I put the connector back together. And it's displaying. Huh. I don't know if it shows up on screen, but this is jittering around a bit to the right and left, entire images. I put my finger there. Oh, let's see. You can see it move. But that's a huge improvement from before. So I just need to find a way to stabilize the sync. I'll probably use one of these little thingies. Let's see. I'm pretty sure I have some LMs. Oh, entire tube of them. These are LM1881. I think so, yeah, LM1881. And these are sink strippers. So these strip out the sink from video signal and cleans it up. So maybe with one of these in between here and the sink, we should be golden. So I'll have to test out a few things, but that seems to be where I'm at right now. So I'm happy with the result at least. And as a strange bonus, now for some reason, if I change the pots, it changes the color. So that's the intended intended way it should work. So that's fine. Okay, I got it to work. I had to put a big capacitor over the power input. It's just that cable going to the TV. Pretty decent, considering I knew we need a filter. So that's really good.
Thank you for watching until the end. This was a really special video for me. It's my first project video with PCBWay. Go give them some love on their webpage. They have really cool stuff. The next video will be the ZX Spectrum keyboard I designed. Hopefully that works as well as this did. See ya. Bye.